Hello guys, welcome back to STEM Trainers. Now today we are going to see year 2 mechanics topic, that is forces and friction. So in year 1 you must have done a topic in mechanics, that is forces and motion. So this is an extension of that topic. So let's see how to solve questions based on this. So this is our first question. A particle of weight 20 Newton rests in equilibrium on a smooth inclined plane as shown in the diagram. Find the value of force P, magnitude of normal reaction between plane and particle. Okay. So whenever a forces and friction question comes, the first thing that we do is, first we in the diagram on the particle, what are the forces acting? We draw a diagram of that. So as already it's shown that P force is there, a horizontal force of 5 Newton is there. Now there will be a weight, or you can say mg force. So this is my 20 Newton force. Now there will be a normal reaction by the plane on the particle. So it will be perpendicular to the surface. So this is my surface. So it will be perpendicular to that. So there will be a normal reaction force. So these are the four forces that are acting on the particle. So that's the first thing that I do. Second thing is, then I think about, okay, whether the particle is having an acceleration or not. It's given that particle is in equilibrium. It rests. So it means the acceleration is zero. It means sum of net forces on this is zero. So it means now you have to think in which direction you have to resolve your forces. Now as the surface is this, as you can see, this is my surface on which the particle is resting. So I will resolve the forces parallel to this surface and perpendicular to this surface. So parallel to this, sum of forces will be zero. Perpendicular to this, sum of net forces will be zero. So that is the logic that we are using. So let's resolve first parallel to the surface. Parallel to the surface. You don't have to write this. I am just writing this just for explanation. In exam or in while solving, you don't have to write this. Okay, so parallel to surface. So what are my forces? So now this P force is at an angle of 30 degree. So it means this, if you resolve the components of P, so parallel to surface will be P cos 30 degree. And perpendicular to the surface will be P sine 30 degrees. So these are important. How to resolve the forces? You must have done this in year 1 also. So if this is P, parallel to surface will be P cos theta, and then the vertical component will be P sine theta. And similarly, we have mg. So this angle is 45 degree, correct? So adjacent to this, so this component will be 20 cos 45 degree. And perpendicular to this, the component will be 20 sine 45. Now we will resolve our forces in the directions that we need. And what about 5? Okay, so this angle is 45. So obviously this angle is also 45, right? Because this is horizontal, vertical, total angle is 90. As you can see, this is horizontal. MG is always vertical. So this angle is 90. This is 45, and automatically this angle will also be 45. Okay, so what are the components of this? So this component will be 5 cos 45, and the vertical component will be, this component will be 5 sine 45. I hope it's clear. So now we have resolved the forces in the directions that we want. Now let's write the equations. So first is parallel to surface. So parallel to surface, what are the forces that are acting in the, I will say this left direction. This is not actually left direction, but let's say parallel to surface on the left. So what are the forces? On the left, we can see we have this 20 cos 45. We can see we have this 5 cos 45. And in the right, you can see we have P cos 30. Right? So it means 20 cos 45 degree plus 5 cos 45 degree should be equal to P cos 30 degree. Because in this direction, particle is not moving, so left side force should be equal to right side force. Or you can say total sum is 0. In that case, you will write the equation as 20 cos 45 plus 5 cos 45 minus P cos 30 equals 0. It's the same thing. I think we discussed in forces and motion chapter. You can do it anyway. It doesn't matter. Okay. So this is very good. So from this, we can easily calculate the value of P, I think. Okay, let's calculate. So this will be 20 cos 45 is square root of 2. So 1 over 2 plus 5 over root 2 is equal to P cos 30. Cos 30 is nothing but square root of 3 over 2. So from this, my P value is coming out to be 25 into square root of 2 divided by square root of 3 newtons. So this is my P force. So let's calculate this value. This is coming out to be approximately 20.412 newtons. So this is my answer. Newtons. I hope it's clear. So this is my answer for A part. Now next, find the magnitude of normal reaction. Okay. So for normal reaction, as we can see, normal reaction R is in direction perpendicular to the surface. So let's write the equation perpendicular to the surface. So what are my forces? So upward force, I will call this as upward, basically surface, from the surface upwards. What are the forces? P sine 30, R, 5 sine 45. So all these three are in upward direction, and in the downward direction you have is only 20 sine 45. So let's write them. So 5 sine 45 degree plus reaction force R plus P sine 30 degrees is equal to the downward force, that is 20 sine 45 degree. So write very carefully, take your time. It's okay because you might be starting this chapter. So let's write these forces. Now we have the value of P. So let's calculate the value of R. So R will be nothing but, when you calculate this, it will come out to be 0.4 newtons. So this is our answer. Because we already know the value of P, so we can substitute the value of P from A part and we can calculate the reaction force. So that's your answer. Okay, let's try one more question. Now this time we will try a friction question. Let's see the question. A mass of 8 kg rests on a horizontal plane, horizontal rough plane. Okay, so let's draw the diagram. So we have a horizontal plane and there is a particle, or let's take it like this, 8 kg. Okay. The coefficient of friction between mass and the plane is 0.5. Okay, so the mu between these two is 0.5, coefficient of friction. Find the magnitude of the maximum force P which acts on this mass without causing it to move. Okay, first case is the force P is horizontal. Okay, so now P is horizontal, you can take it in any direction, it doesn't matter, it should be horizontal. So let's take P in this direction. Now, when P is trying to pull this object to the right side, so what will happen is friction will try to resist this. So friction force F will act in backward direction, that is towards left. So this will be our diagram, and we obviously know there is mg downwards, that is 8g. There is a normal reaction R perpendicular to the surface. Remember, normal reaction is always perpendicular to the surface. It's not always vertical. Mg is always vertical downwards, but R is always perpendicular to the surface. As you can see here also, we have taken in this case reaction force in this direction because it is perpendicular to the surface. Okay, now next thing. So first part is P is horizontal. So we need to find the maximum value of P. Let's first write the equations. So in vertical direction, what's happening? In vertical direction, if this is not moving, this mass is not moving, then this R should be equal to 8g. Right? Next is in horizontal direction, what's happening? So in horizontal direction, there is a force towards right, there is a force towards left. So they should be equal. Hence, the system will be in equilibrium. So what we can say is F should be equal to P. Right? Now the maximum value of P will be whatever the maximum value of friction force is. Right? So maximum value of friction force we know is mu times R. F friction maximum value we know is limiting case, in that it is mu times R. That's a maximum value. In all other cases, what happens is friction is always less than this. I think you know this. If you don't know this, you can just remember this now. So maximum value of friction will always be mu times reaction force. Okay. Now, so it means P should be equal to mu times R for P to be maximum. So let's calculate the value. Mu is 0.5 into R is 8 times G. Let's take G as 9.8. So this value is coming out to be 39.2 newtons. So that is our answer. So this is the maximum value of P. Now if you apply P greater than this value, that is 39.2 newtons, what will happen is this mass will accelerate towards right. Now what will happen if you apply P, a force that is less than 39.2? The system will remain at equilibrium. And at every point of time, what will happen is if P is less than 39.2, friction force will be always equal to P. So for example, if I apply a horizontal force of 15 newtons only, then my friction force will be only 15 newtons, not 39.2. Remember this. Okay. So this is important. So friction depends on the forces. The limiting case is the maximum friction that can occur between the particle and the surface. Okay, let's try the B part now. So B part, it says the force is acting at an angle of 60 degree to horizontal. So let's draw a diagram. So horizontal surface is there, mass is there, 8 kg. A force is acting at an angle of 60 degree. So this is my P. Okay. Now, friction is acting in this direction. Again, this is my normal reaction R. This is my mg 8g. Okay, so this is our diagram. So now again, they are saying that system is not moving. So system is not moving means the horizontal forces and vertical forces are equal. They are balanced. And now we need to find the maximum value of P. So again, I will write the equations. Now this time, now this is my surface, right? Remember in first question what we talked about, surface. So we need to resolve all our forces parallel to the surface and perpendicular to the surface. So F, R and mg, that is 8g, are already parallel or perpendicular, but this P is acting at an angle of 60 degree to horizontal. So this component parallel to surface will be P cos 60. And the component that is perpendicular will be P sin 60, right? So this is my P, this is 60 degrees. So this horizontal will be P cos 60 and vertical is P sin 60. So now let's write the equation in horizontal direction. and in vertical direction one by one. So in horizontal direction, left side a force F is acting, that is the friction force, and no other force is there on left. On the right hand side, my force that is acting is P cos 60 degree. So this is my equation. Now, next is in vertical direction. In vertical direction, what's happening is R plus P sine 60 degree is equal to the downward force, that is 8G. Now, if you want P to be maximum, as you can see from this first equation, so if you want P to be maximum, then obviously friction force should be maximum. And what's the maximum friction force? Mu times R. So we know this, coefficient of friction into reaction force. So we can substitute the value of R. So what I'm getting is P cos 60 degree is equal to mu into R. What is R? R is nothing but 8G minus P sine 60. So this is my equation. So what is my P value here? So P cos 60 degree is equal to, mu is 0.5, so this will be 4G minus 0.5 P sine 60. So let's take all P terms on left side. So cos 60 degree plus 0.5 sine 60 degree is equal to 4G. So my P value is coming out to be 4G divided by cos of 60 degree plus 0.5 sine of 60 degree. So let's substitute the values. So this will come out to be approximately 42 newtons. So this is my force P. So that's my answer. I hope it's clear. So you can see that also when you are applying P horizontally, the maximum force that you can apply so that system is in equilibrium is only 39.2. But when P is acting at an angle, you can apply a larger force so that the system is still in equilibrium. Just an observation. Okay, so in the next video, what we are going to see is, we are going to see more of the cases when friction is there and inclined plane is there or pulley is there. So that's it for this first video, that is the introductory video. So we will see more in the next coming videos. Thanks for watching.